All right, so today we're going to be taking a deep dive into, this is a research paper, and it's called The Curse of Depth in Large Language Models.
Okay.
Now, you actually provided this one, so you probably already know that LLMs, large language models, are
Right.
behind like things like ChatGPT and Bard and, all
The rage.
all the rage these days,
Yeah.
right? But get this, some of them are basically wasting processing power
Yeah.
on layers that are like barely doing anything.
Interesting.
So we're going to try to figure out why that is and what it means for like the future of these AI giants.
Yeah, it's really interesting. It really challenges our assumptions about how these models learn.
Yeah.
And the paper, it calls this phenomenon the curse of depth, or CUD. And it's pretty counterintuitive, right? You would think that the deeper layers, the ones built on, all that previous learning,
Right.
would be where the kind of the magic happens.
Right. It's like you build this skyscraper and then you find out that the top floors are just like empty shells.
Exactly.
So what's going on? I mean, did the researchers find like any specific examples of this cove in action?
They did, yeah. So in their experiments, they actually pruned layers from several well-known LLMs.
Okay.
For instance, they found that removing, get this, over half of the layers in LMA 213B
Wow.
had almost no impact on its performance.
Really?
Yeah.
Wow.
And it's a similar story with some other models too, like Mistral 7B and Qwen 7B. They could just like axe the last third of their layers with barely any change in how they function.
That's wild. Okay, but you mentioned earlier, but this isn't a problem with all LLMs.
Right.
So like what makes these particular models different? Why are they?
Right, that's the key question. And the researchers believe that the culprit is a technique called pre-layer normalization,
Okay.
or pre-LN for short, which is used in a lot of these models.
Okay.
So to simplify, pre-LN is kind of like hitting a reset button.
Yeah.
On the data at each layer during training, it's meant to prevent like wild fluctuations and kind of stabilize the learning process.
So it's kind of like a safety valve on a pressure cooker, right? Keeps things from like going haywire.
Exactly.
Yeah.
Exactly. But here's where it gets interesting, right? So while pre-LN helps with stability,
Okay.
it seems to unintentionally cause an exponential increase in something called data variance.
Okay, hold on. Data variance.
Yes.
What exactly does that mean and why is that a problem?
So think of it this way. Imagine you're playing a game of telephone, right? You start with a clear message, but as it gets whispered, from person to person, it gets distorted.
Yeah.
So the time it reaches that last player, it's barely recognizable.
Right, so the message, or in this case, like the data gets more garbled, like the further it travels.
Precisely.
Yeah.
And in the context of LLMs, that garbling, that variance, means the data reaching the deeper layers is essentially just noise.
So those deeper layers that we thought were doing like all the heavy lifting
Right.
are actually being fed like junk information. No wonder they're not contributing much.
Yeah, exactly.
Okay, but what's causing this variance explosion in the first place? I mean, is it just like a side effect of pre-LN?
That's what the research suggests.
Okay.
Yeah, and it comes down to the math behind how pre-LN transforms the data at each layer. So without getting too technical, the way it's implemented, it leads to this kind of snowball effect.
Okay.
Where the variance just keeps amplifying as you go deeper.
Okay.
Right. And by the time you reach those final layers, the outputs are practically meaningless.
So it's like trying to learn from like a textbook that's written in a language you don't understand.
Exactly, yeah.
Okay, so we've got these powerful LLMs,
Right.
but some of them are like essentially crippled by this curse of depth
Right.
caused by pre-LN. Is there any way to fix it?
Well, there is, and that's what we'll be exploring in the next part of our deep dive.
All right, I'm on the edge of my seat. I can't wait.
Okay.
Let's find out if there's hope for these like brain-damaged AI giants.
All right.
Okay, so we've established that this curse of depth thing stemming from pre-LN is causing some serious inefficiency in certain LLMs.
Yeah.
But you hinted that there might be like a fix for this. What did the researchers find?
Yeah, so the good news is that they proposed a solution called layer norm scaling.
Okay.
And it's surprisingly simple, so it's basically a tweak to pre-LN that aims to kind of control that variance explosion that we talked about.
Okay, but how does like scaling down the variance actually help? I mean, does it just make the data less noisy?
That's part of it, yeah.
Okay.
So by scaling down the variance at each layer,
Yeah.
layer norm scaling, it prevents that snowball effect that we were talking about.
Right.
It's like, imagine turning down the volume knobs on those whispers in the telephone game.
Okay.
Right? So the message, the data, stays clearer as it passes through the layers.
Right.
And so the deeper layers actually get useful information to work with.
Oh, that makes sense. So does this tweak actually translate into like real world improvements for these LLMs? Like, does it actually make a difference?
It does, yeah. The researchers found that layer norm scaling, it led to several benefits.
Okay.
First, it actually improved the overall performance of the LLMs. So they saw lower perplexity scores.
Okay.
Meaning the models were better at predicting the next word in a sequence, which is a key indicator of, language understanding.
So it's not just about making the models more efficient, it's like actually making them smarter.
Exactly, yeah. And it goes beyond that.
Okay.
Layer norm scaling also makes the training process more stable.
Uh-huh.
Especially for, these massive LLMs that require huge amounts of computing power.
Right.
And this is particularly relevant given, the growing concerns about the environmental impact of training these AI behemoths.
Well, that's a perfect segue, actually.
Yeah.
Speaking of impact, like, what are the broader implications of this whole curse of depth thing and its potential solution? I mean,
Right.
why should, like, people outside the world of AI research care about this at all?
That's a great question. So on the practical level, the curse of depth highlights the fact that we're potentially wasting enormous amounts of computing power
Uh-huh.
and therefore energy on layers that aren't really contributing much.
Right.
Think about, thousands of GPUs running for months
Yeah.
to train these models. So if we can make them more efficient with something like layer norm scaling,
Right.
that translates to, significant cost savings
Yeah.
and a reduced carbon footprint.
It's a reminder that even in like cutting edge fields like AI, there's always room for like optimization and a need to consider like the real world costs of these things.
Absolutely. And beyond the practical implications,
Yeah.
I think this research raises some pretty fundamental questions about how we design and develop complex AI systems.
Uh-huh.
It shows that even seemingly straightforward techniques like pre-LM
Right.
can have unintended consequences.
Yeah.
And those consequences might not be immediately apparent.
Right.
It takes, careful analysis and experimentation to uncover them.
So it's kind of like we're building these incredibly powerful machines,
Yep.
but we don't always have a complete blueprint
Right.
of how they operate.
That's a good analogy.
And as we rely more and more on AI for like everything from medical diagnoses to financial decisions,
Right.
it's crucial that we don't just focus on like building bigger and more impressive models. We also need to invest in understanding like the fundamental principles of how they work, how they learn, and what potential pitfalls might arise.
Absolutely. So while this curse of depth might seem like a very specific problem,
Yeah.
it actually speaks to this much larger need for transparency
Uh-huh.
and critical analysis in the field of AI.
Exactly. And that's something we should all be aware of. I mean, whether we're like AI experts or simply users of these technologies,
Yeah.
we need to be informed, ask questions, and man that these systems are developed responsibly and ethically.
Well said.
Well, this deep dive has certainly opened my eyes to to some of the like hidden complexities of LLMs.
Yeah.
But I'm also feeling a sense of hope knowing that researchers are actively working on solutions like layer norm scaling.
Yeah.
What's fascinating to me is that something so seemingly simple can have such a profound impact.
Yeah.
It makes me wonder, like, what other elegant solutions might be out there just waiting to be discovered.
Yeah, I agree. And that's what makes this field so exciting, right? There's so much we're still learning and discovering about AI.
Yeah.
And those discoveries have the potential to shape our world in profound ways.
Speaking of shaping our world, I'm curious to hear your thoughts on like the potential long-term impact of research like this.
Yeah.
What does the future hold for LLMs, and how might these findings influence the development of AI in general?
That's a big question.
Yeah.
And one that's difficult to answer definitively, but I think this research highlights a couple of key trends
Okay.
that are likely to shape the future of AI.
Okay.
First, there's a growing emphasis on efficiency,
Okay.
right? As we build, larger and more complex models,
Yeah.
we need to be mindful of the resources required to train and run them.
Uh-huh.
This means finding ways to optimize their architecture, like addressing the curse of depth
Right.
and exploring new training methods that are less energy intensive.
So it's not just about making LLMs smarter, it's also about making them more sustainable.
Precisely. And this ties into the second trend that I see, which is a greater focus on understanding and addressing the limitations
Okay.
of AI systems.
Okay.
right? As we've seen with the cursive depth, even well-established techniques
Right.
can have unintended consequences.
Yeah.
So this means we need to invest more in research that goes beyond just simply improving performance
Yeah.
and focuses on understanding the inner workings of these models,
Mhm.
identifying potential biases,
Right.
ensuring their robustness and reliability.
So it's about making sure these powerful tools are used responsibly and ethically, which is, something we've touched on throughout our conversation.
Absolutely. The future of AI is not just about building smarter machines, it's about building smarter systems
Yeah.
that are aligned with human values
Yeah.
and that benefit society as a whole.
Right, and that brings us back to like the importance of deep dive, like this one, by shedding light on like the inner workings of AI.
Right.
We can empower ourselves to make like informed decisions about how these technologies are developed and deployed in the future.
Yeah.
But before we wrap things up, is there anything else you'd like to add about the cursive depth or
Sure.
the potential of layer norm scaling?
I think we've covered the key points, but I do want to emphasize that this research is just one piece
Okay.
of a much larger puzzle.
Yeah.
The field of AI is rapidly evolving,
Uh-huh.
and new discoveries are being made all the time.
Right.
But what's exciting is that we're starting to see a shift
Okay.
from a purely performance-driven approach
Uh-huh.
to one that prioritizes understanding, efficiency, and responsible development.
Right.
And that's a positive sign for the future of AI.
Absolutely. And on that optimistic note, let's wrap up this deep dive.
Sounds good.
Thanks for joining us on this journey into the fascinating world of LLMs and for sharing your expertise on this cutting-edge research.
Oh, it's been my pleasure.
All right, and to our listeners, we encourage you to keep exploring, keep learning, and keep pushing for a future where AI benefits all of humanity.
And if you're interested in learning more about the cursive depth and other fascinating topics in AI, be sure to check out the links in the show notes.
Awesome.
Until next time, stay curious.
It's kind of crazy to think that like a small tweak, like layer norm scaling,
Right.
could be the key to like unlocking so much potential in these LLMs.
Yeah, it's pretty amazing.
Really underscores that idea that progress in AI isn't always about like creating something totally new, but rather just like
Right.
refining and optimizing like what we already have.
It is. Yeah, it's like polishing a diamond
Yeah.
to reveal its full brilliance.
Right. And in the case of LLMs, that brilliance translates to like more efficient learning, reduced resource consumption, and ultimately like more powerful and reliable AI systems.
Exactly.
But it also makes you wonder like what other seemingly minor adjustments
Yeah.
could lead to like significant improvements.
Right.
Are there any other areas of LLM design
There are, yeah.
that researchers are focusing on for optimization?
Oh, yeah, there are many exciting avenues being explored right now. One area of focus is on developing new training methods that require less data
Okay.
and less computing power.
Okay.
For example, there's something called few-shot learning,
Okay.
where models can learn new tasks with just a handful of examples,
Okay.
rather than being fed, millions of data points.
So instead of needing like a whole library's worth of information,
Right,
these models can learn from just like a few pages, so to speak.
exactly. And that has huge implications for reducing, the environmental footprint of AI.
Yeah, for sure.
Another fascinating area is research into making LLMs more adaptable and robust.
Okay.
So right now, they tend to be very specialized, good at one task, but not so much at others.
So they're like experts in one narrow field, but can't really generalize their knowledge
Right.
to other areas.
That's a good way to put it, but researchers are working on creating, more general-purpose LLMs
Uh-huh.
that can adapt to new situations and solve a wider range of problems. So imagine an LLM that can not only, write a poem,
Okay.
but also help you analyze a scientific paper and plan your next vacation.
That would be incredible, like a true jack of all trades AI.
Exactly.
It seems like the possibilities are almost limitless,
Yeah.
but we need to make sure we're moving forward with caution and foresight.
Right.
This whole discussion about the cursive depth has really highlighted the importance of understanding like the potential pitfalls
Yeah.
as we develop these increasingly sophisticated systems.
Absolutely. We need to avoid falling into the trap of simply chasing bigger and more complex models
Yeah.
without fully considering, their implications. It's like building a rocket without checking if the fuel is safe.
Right, right.
We need to make sure we're not creating systems that are powerful but potentially unstable
Right.
or harmful.
So what are some steps we can take to ensure that AI development progresses in like a responsible and ethical direction?
Well, first and foremost, I think we need greater transparency in how these systems are developed and trained. We need to know what data they're being fed, what biases might be present, and how their decision-making processes work.
Yeah, it's hard to trust something if you don't understand how it works.
Exactly. And we need, clear guidelines and regulations for how AI is used in different sectors, whether it's healthcare, finance, or law enforcement. We need to make sure these technologies are being used to benefit society as a whole, not just to advance the interests of a few.
Right, and it's not just about like the developers and the policymakers. As individuals, like we also have a responsibility to stay informed about these issues.
Absolutely.
And to engage in like thoughtful discussions about the future of AI.
I couldn't agree more. The more we understand about these technologies, the better equipped we'll be to navigate the challenges and opportunities they present.
This deep dive has been a fantastic reminder that progress in AI isn't just about like technological advance teams.
Right.
It's also about having like thoughtful conversations, asking critical questions, and ensuring that these powerful tools are used for good. So to our listeners, we encourage you to keep exploring, keep learning, and keep pushing for a future where AI benefits all of humanity.
And if you're interested in learning more about the curse of depth and other fascinating topics in AI, be sure to check out the links in the show notes.
Awesome.
Until next time, stay curious.